These workers are from the oil industry. They're using the same tools, the same science.
We wouldn't even know this resource existed if it weren't for the oil and gas industry.
But here, what they're looking for, more than 3.5 kilometers below, is water. Water so hot, you can use it to generate electricity.
All right, that's amazing. That's very cool.
Thanks to this project, named DEEP, Canada might soon have its very first geothermal power plant.
We're going to be producing power very quickly here.
This is southeast Saskatchewan. Geologist Kirsten Marcia grew up here, surrounded by crops and oil wells. And it's here she wants to spark a green revolution in the energy field.
I've been developing resources as an exploration geologist my entire career. And we looked at geothermal as a unique resource where, as long as the center of the Earth is hot, we've got an inexhaustible, clean baseload power supply. Once geothermal is installed, it runs 24/7.
Yet, in this part of the country, there are no volcanoes. The resource is hidden deep underground, in rocks that are 500 million years old. It's very hot, salty water, 125 degrees Celsius. To give us a better look, the team hired a drone pilot equipped with a rather special camera.
You see, holy smokes. Look at the temperature difference between that tank and that tank.
Thanks to its infrared vision, we can see the heat directly, even though it was a really hot day. The air was 38 degrees, and the ground was even hotter. Workers, by contrast, looked cold. You can clearly see the water pumped from one of the wells and stored in tanks.
That looks hot.
92.9 we're reading right now on the outside of that tank.
For me, this is amazing to actually see it. I mean, when you look at the tanks, you know there's hot water in there, but to actually see it visualized like this is pretty cool for us and our team.
Geothermal in itself is not new. But in Canada, it's never been used before to generate electricity. And for that, you need a lot of this hot water.
Geothermal uses massive volumes of fluid. So that tank farm back there, on a daily basis, we're going to fill and inject about 1 hour of those tank farms. So this is a huge water moving process.
To pump that much water, Kirsten Marcia also needed very specific rocks to allow the fluid to move around. Her treasure hunt began here. These archives contain core samples of everything that's been drilled in Saskatchewan, whether it's to find oil, diamonds, gold, uranium, or potash. But what she was after were actually holes.
So this is a sandstone that has really great porosity, and that porosity is connected so that the fluid can move through the rock.
The other main ingredient is the temperature. And she found it in public data somewhat by chance.
So when you drill a well, you do what's called geophysical logging, and of course temperature is one of the readings that's also taken. Interesting, it's actually usually just used for calibration, but in our case, temperature was the key piece and what we were looking for.
Both temperature and porosity pointed to rock formations deep below her home region along the US border.
This is a sweet spot, so within the stack of pancakes, that is the sedimentary units that host all of these resources, there is a particular sweet spot that is more permeable than the rest, and is going to flow better for us.
That explains the design of the first power plant. The next drilling goes down 3.5 kilometers, and once in the sweet spot, the well becomes horizontal for another 2 kilometers. A twin well will go in the other direction. And further north, 2 more pair of wells will join them.
So the hot water comes out of the ground, we pump it, we run it through a heat exchanger, So we harvest the heat out of that brine, and that's where we're done with it. So now we've got the heat, and then we introduce it to a working fluid. In our case, probably butane. That butane goes from the liquid phase to the vapor phase, and that's what turns the turbine. It's actually called binary cycle because you've got a loop of this refrigerant running, and then you've got a loop of your hot brine, coming up hot, going back cold for reheating.
The water, now at 65 degrees, is re-injected between the pumping wells. As it percolates through the rocks, it picks up heat little by little. The question is how much distance you need between the different wells. That was precisely the focus of the test carried out during our visit. For weeks, the team pumped water, added a chemical tracer, and re-injected it 750 meters further. That way, one can measure how long it takes for the water to move through the rock before it's picked up again. The first plant will generate 20 megawatts of electricity, enough to power 20,000 homes. The team is already scouting locations for a second plant that will produce another 20 megawatts. This well goes to a record depth, more than 3.7 kilometers. To test it, a pressurized gas is injected at the very bottom. After a few hours of waiting, the gas rises back and the water starts flowing. The key information, of course, is the temperature. But a chemist also analyzes its composition, looking especially for salts that could accumulate in tanks or pipes. They are also checking for bacteria, which could proliferate and clog the pipes or cause them to rust.
We don't want to get a surprise. The resource could vary a little bit better, a little bit worse, but the quicker that we understand the nature of it, the better. Right, well, we expect that this to be very, very similar to the other wells. One of the things that we've learned about this resource is that it's very, very consistent, very predictable. But because this is a fairly big step out, this is really going to test that theory that this is a very consistent resource. We want to take a big step out to see if there's any subtle changes.
Geothermal power plants never use all the energy contained in the water. Elsewhere in the world, the water is still warm enough to heat swimming pools, fish farms, greenhouses, or even sidewalks during the winter. Kirsten Marcia believes geothermal can help her region diversify its economy and go green without turning its back on the oil workers.
We've got this unique situation where we can draw upon all of the world-class expertise, all of the world-class technology to develop this resource. If you looked across Canada, there wouldn't be a better location that's already pre-set up to drill these really amazing wells. It's perfect. And we can then use the oil field workers and redeploy their skills for the first time ever on a renewable energy project.